Hi ladies and gentlemen, this is Mr. Green and this is another of my recordings for pre-cal. I appreciate you all being here. This is lesson 4.2. We're doing some identities here. Remember, due dates 28 days after they close, they lock up. So you want to make certain you get them done and you don't get zeros in the grade book, okay? So, identities. First thing I'm going to tell you is don't make this a lot harder than it actually is. It can be quite difficult if you let it be that way, okay? But for the most part, identities just mean making certain you have the uh, uh, the documents in front of you that you need to have, okay? Now I know that sounded kind of weird. It came out kind of weird when I said it, okay? But what you're looking for is to make certain you have the formula charts in front of you, because those formula charts do help you. They have everything on them that you're going to want to have, okay? And what I'm talking about there is, it'll pop up here in a second. Maybe it's not going to pop up in a second. Okay, there it is. It's the study guide. If you go to page 11 in the study guide, it's got the summary of the trigonometric identities. Okay, it starts with the sum and difference identities, and it does the double angle identities and so forth. And as you read through the lesson, it goes into great detail about how to prove these and everything else. You're not going to be asked to prove them, okay? You're going to be asked to use them in the process of what you're doing. So let's not make it more difficult than it actually is. Print that identity sheet out, keep it close at hand, use it when you need to, okay? Substitute things in there when you need to do them. These are the sum and difference identities right here, okay? So I think you'll recognize them. In this particular case, I have a sign of negative x. Well, I happen to recognize that when I do this, I'm actually saying sine of a minus b, where a is equal to 0. Okay? Because 0 minus b would give you, or 0 minus x would give you a negative x. So what is that? Well, I go back to the addition ones here, and I'm looking at this one right here. Sine a minus b is sine a cosine b minus cosine a sine b. I know that came out kind of fast, but that's what it is right there. If I stick a 0 in for a, the sine of 0 is 0. So this is going to go to 0 and it's going to disappear, right? And the cosine at 0 is a 1. So what do I wind up with? Minus sine x. That's what I've got left. And so this, as an identity, is true for every value of x. All I had to do was to substitute in the correct formula, and it worked itself out. So, double angles. If I see something like this, cosine of 2x, what am I going to do? I'm going to go to the double angle formulas. These are the double angle formulas right here. Excuse me. If I see something like this, sine 2a is equal to, well, the first thing I'm going to do is I'm going to come over here and say sine 2a will be equal to 2 times sine a cosine a. Okay? Well, that's sine a, 2 times a, sine a cosine a. Now, is this equal to this? In no way. In no way, shape, or form are those equal. So you would say that's not equal. That's not true for all values of a. But you can see how I did that. Just by substituting this in, I can see that they're not going to be equal to each other. Okay? How about the half angle ones? Well, these are the half angle formulas that they gave us. So I'm going to look at the sine of 45 degrees. Well, 45 degrees is half of 90. So if I were taking the sine of 90 degrees, that would be plus or minus the square root of 1 minus cosine x, which would be 90, divided by 2. Well, cosine of 90 is equal to 0, so that's 1 minus 0. That's 1 over 2. So that's the square root of 2 divided by 2. Okay? Well, how did I get that? Well, I did a little simplifying of the radical here. I got the square root of 1 divided by the square root of 2. Well, that when you multiply this times square root of 2 over square root of 2, what do you wind up with? Square root of 2 over 2. And that happens to be the exact value of the sine of 45. Okay? So I worked it out, showing what that value is every single time. It works out quite easily by substituting that value in there. Okay? How about the squared formulas here? Well, I'm going to use those squared formulas to simplify this one. I've got sine squared u times tan squared u. Well, the sine squared is equal to 1 minus 2x divided by 2. Well, I'm going to replace sine squared with that value right here. Okay? And I put it in here. So I got 1 minus cos 2u divided by 2. Well, the tangent is equal to the sine, tangent squared is equal to sine squared divided by cosine squared, right? That's just like saying that x squared is equal to a squared over b squared, right? That's all it is doing, all I'm saying there, okay? So having this, I then substituted this value in for the sine and the corresponding value in for the cosine, right? Well, this one times this one, okay, it'd be this one times this one divided by 4, and then 2 times this, or this one, divided by 2. Okay? So when I multiply this out, okay, I get this value here. And when I take that 2 times everything, I got this. But here I got another cosine squared, so I turn that into another 1 plus cosine over this. Okay? And when I multiply this 2 out through everywhere, I get this value here divided by the 4, and I wind up with 3 plus 4 cosine of 2u plus cosine of 4u divided by 4 times 1 plus cosine 2u. Worked out just fine. That's what it would simplify to. It takes a little bit of effort, but if you do it over and over and over again, it works fine. Okay? So, the reason I'm giving you this is so that you have a lesson to follow with 4.01 or 4.02. If you have any questions for me, make certain you send me questions. I'm going to be star testing this week. It's going to be difficult to get hold of me. Make certain you let me know that you are in pre-cal when you send me information. I'll talk to you later.